Hey guys, this is Mr. Grice for Algebra II Unit 4.7 Notes, Day 1. Today we're going to be talking about graphing quadratic equations in standard form. Our learning target today is to be able to graph quadratic equations in standard form. So let's go ahead and take a look at what standard form is. Standard form of an equation is f of x equals ax squared plus bx plus c. You guys should be pretty used to the ax squared plus bx plus c because that's what we were looking at when we did a quadratic formula. So if the quadratic term is positive, okay, the quadratic term is whichever one is with the squared, the parabola opens up, kind of like a happy face, okay? So you can see that the parabola, the U shape, is opening up. Now, there's a special point in a parabola called the vertex, and I'm going to show you how to get that in a second. But if the parabola opens up, our vertex is a min, because see, it's all the way at the bottom. So we would say that it is a min. Now, if the quadratic term is negative, the parabola opens down, kind of like a frowny face. And then once again, when I'm looking at the vertex is the middle point. Right now it's at the top. So if it's negative and it's opening down, our vertex, the very top, that is called a max. It's the very top of the graph. So it's kind of backwards. So if it's positive, our vertex is the minimum. If it's negative, our vertex is the max. Now, to find the vertex of the parabola, which is either the lowest or the highest, which we were just talking about, we need to find that value on the graph. And the way we do that, if we don't have the graph, we use a formula. So to find the x value, what we would say is that x equals the opposite of b over 2a. Okay, it's not the full quadratic formula, but there you go. So we do the opposite of b over 2a, and then to find the y, what we do is we would substitute the value of x into the function. Okay, so first we find out what x is, and then we substitute it into the function. All right, so graph by using a table. F of x equals x squared. So this is called the parent function. We talked about the parent function a lot when we were doing absolute value graphs. So what we're going to do is we're going to plug each one of these in to a calculator. Now normally, we can do it off to the side. So first, sorry, coming back over here, we have -2 squared. You should know this, but if you don't, you're taking -2 in parentheses and squaring it, and we get 4. So when we plug in -2, we get 4. If we're plugging in -1 squared is 1. And if you don't believe me, use your calculator. -1 squared is 1. Now, 0 squared, yeah, you should know that. 0 squared is 0. 1 squared is 1, and 2 squared is 4. Oh, sorry, wrong number. So 1 and 4. So what I'm going to do is we're going to graph that. We've got 0, 0. If you notice, my quadratic term is positive, so we're going to be opening up. And I've got 1, 1, I've got 2, 4, and over here we got -1, 1, and -2, 4. So this is what our parabola looks like. Okay, we want to make it nice and smooth, and it's opening up. Now, the general pattern for the first 5 points on a parabola, if a equals 1, and we were just like saying, hey, look at that first guy is 1. So here, our a equals 1, our general pattern from the vertex, okay, the vertex is the middle point, and this is from the vertex how we get to each point. Okay, so to get to the first point, I go up 1, over 1. Okay, so what we did for the first one is we went up 1, over 1. To get to the second point, I need to go up 4 over 2. So up 4 over 2. And if you notice, that works both ways. I go up 1, over 1, up 4, over 2. And it works for both, all of your points. Okay? So what we're going to be starting with as we come down here is we were going to determine whether the function opens up or down, and if the vertex is a max or a min. Then we're going to find the coordinates of the vertex. Okay? So the first thing I want to know is, does it open up or down? And I need to look at the quadratic term. Okay? So there's my quadratic term. A equals -1. Okay? So if a equals -1, I know that it's going to be opening down. Okay? So it opens down. So our vertex all the way up at the top is a max. So opens down. So vertex is a max. Okay? We didn't do anything. All we did was look at the quadratic term. Okay? Now the next part is to find the vertex. So to find the vertex, we got to say that x equals the opposite of b. So it's a -6, so we've got to have a +6, all divided by 2a. And we said that a is -1. So as we're solving this, 6 on the top, 2 times -1 is -2. So 6 divided by -2 is -3. Okay, so this is nice. In my final answer, I know that my x value is -3. I just have to figure out what my y value is now. So to figure out the y value, we're going to take our function and I'm going to plug in -3. So I have -x² minus 6 times -3 plus 9. And we're plugging in this -3. Okay? And for that, you can just plug everything into your calculator. I've got that -1 out front. I'm timesing that to -3 squared minus 6 times -3 plus 9. And then we're going to get a positive 18. So when I plug in -3, my answer is a positive 18. So then we get the point -3, 18. Okay? So example number 2, sometimes they're not going to be in order, but we need to find that quadratic term. Okay? So there's my quadratic term. It's positive, and if it's a +1, that means it's going to open up. So if it opens up, our vertex, which is the middle point, so since it opens up, we would say, so the vertex is min. It's a minimum. It's the bottom of the graph. Okay? So now we have to figure out what the vertex is. We would say that x equals the opposite of b, so it's going to be a positive 8, all divided by 2 times a. So on the top is 8, 2 times 1 is 2, and then we get 4. Okay, so my vertex, I know that the x value is 4. To find the y value, we plug it in. So I'm looking back at my equation, and I'm just waiting for my pen to start working again, so hold on. Okay, so I started to write down that equation. We know that we're going to plug in 4 this time. Okay, so here we go, plugging in 4. And then once again, just do it the easy way, plug it in. So I have negative 8 times 4 plus 4 plus, I'm sorry, that's plus 1 plus 4 squared. Okay, and it's always good to double check, look back in, and then let's figure out what it is. And we get negative 15. So G of 4, let's make that look like a 4, equals negative 15. Okay, that's my answer. So for number 3, first thing we do is we try to find our quadratic term, because the quadratic term tells us what's going on. So we know that a is negative 3, and if it's negative, that means it opens down. Okay, so it's opening down. Since it opens down, our vertex is a, max. All right, let's go ahead and pause the video to see if you can find out what your, x value is. The opposite of b is 12 over 2 divided by a, 2a, and then after that, you're going to plug in to your equation. So we have 4 minus 12x minus 3 times x squared. Okay, go ahead and pause the video and good luck. Okay, and you should have gotten negative 2 and positive 16. All right, let's look at the next part. So the axis of symmetry. What the axis of symmetry is, it's a vertical line that cuts the parabola exactly in half. Okay, so what I'm doing is I am looking for where I can draw a line, and this line goes directly through the vertex. Okay, so here's my vertex right there. That line cuts it exactly in half, which means I could fold it up. They call it axis of symmetry because the line of symmetry is where you can fold something directly in half and both sides are the same. Okay, so what we're going to do is, and of course the equation of that is the same equation as your x value in the vertex. Okay, so graph the function and find the equation, its axis of symmetry. So the equation, the first thing that we have to do is find the vertex, and then we're going to graph it, and we're going to do the axis of symmetry. So we're going to look at our x value, and I know that a equals 1, so that tells me we're going to be opening up, and my vertex is a min. Okay, so here's my goal. I want to find the vertex. To find the vertex, the first thing we do is we know that x equals the opposite of b. So I have a positive 2, so it's going to be a negative 2, all divided by 2 times a. So on the top, we get negative 2 divided by 2, which is negative 1. So I know that negative 1 right here, that is our axis of symmetry. I can draw this line right here even before I do anything else, and I know that this line is going to cut my parabola directly in half. Okay, now what I'm going to do is I'm going to plug in f of negative 1 equals negative 1 squared plus 2 times negative 1 minus 5. And we're going to plug in negative 1 to find out what our y value is. Okay, so we have negative 1 squared plus 2 times negative 1 minus 5. And when we do all that, we get negative 6. So there we go. We found our vertex. Negative 1, negative 6. So negative 1, negative 6. And just like we said, that's what the axis of symmetry goes through. And then I'm going to go up 1 over 1, up 4, 1, 2, 3, 4 over 2. Up 1 over 1, 1, 2, up 4 over 2. Okay, and we're just following the pattern that we talked about at the beginning. Okay, so I'm going to write that again, that we went up 1 over 1, up 4 over 2. Okay, now there is another way that we can graph this, and I want to show you. So I'm going into my y equals, okay, and our equation is x squared plus 2x minus 5. Okay, and if you hit graph, it's going to graph the parabola for you. So this is a way for you to double check everything. Okay, you can also go to your table, and if you see the y values, how they're going up, down, 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 and then at negative 1, negative 6, you can see that that's the lowest point. That's your vertex. And then it goes up, 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 up again. Okay? So I would always highly recommend that you use your graphing calculator to help you out. So we're going to call that it for the first side of the notes, and video number 2 will be the back side. Okay? Well, this is Mr. Grice signing off for Algebra 2 Unit 4.7 Notes, Day 1, video number 1. Thanks for watching.